Hello friends, in the previous video we looked at a numerical method called bisection method. In this video we are going to look at another numerical method called Regula Falsi or false position method. So Regula Falsi or false position method can be used to solve a nonlinear equation. This method is also called a linear interpolation method. Regula Falsi method belongs to a group called closed domain or bracketing methods. The nonlinear equation f of x equals 0, for example, could be an algebraic equation, a transcendental equation, etc. An algebraic equation typically consists of x, x squared, and other powers of x. A transcendental equation, in addition, can consist of trigonometric, logarithmic, and exponential functions. Some examples of nonlinear equations are given below. The first one is an algebraic equation. The second one is a trigonometric equation. The Regula Falsi method is depicted in the graph below. So we need to find the root for the function f of x. So we need to find x value at f of x equals 0. So in this case, the exact root alpha we need to find the exact root alpha. So we need to identify 2 points A and B between which the exact root lies. What we do first is instead of f of x, we consider a line between f of a and f of b, and we call it g of x. So we are linearizing the nonlinear function, and we identify the location c based on that. So if f of a times f of c is a negative value, then we know that the root lies between a and c. But if f of a times f of c is a positive value, then we know that the root should lie between c and b. If the root lies between c and b, we update a to c and b remains the same. The algorithm for Regula Falsi method is given below. G dash of x is the slope of the line, which is equal to f of b minus f of a by b minus a. G dash of x is also given as f of c minus f of b by c minus b. And since f of c equals 0, we can obtain c minus b equals f of c minus f of b by g dash of x, and we can obtain c equals b minus f of b by g dash of x. So in the bisection method, we used c equals a plus b by 2, but in the Regula Falsi method, c is obtained by c equals b minus f of b by g dash of x. And how do we get g dash of x? So we can get g dash of x from equation 1, that is f of b minus f of a by b minus a. So we need to use equation 1 and equation 3 to solve our root. We can now go to the MATLAB program and try to solve our the second problem. So the transcendental problem, f of x equals exponential e power x minus 2 times x minus 2. And we picked a and b as 0 and 2. The number of iterations n is set at 100. And the algorithm is presented here as we discussed. We can even make this greater than or lesser than or equal to 1 e minus 6. Okay, so we now run this program, and we only used 12 iterations here, and the root is calculated as 1.678347, and at this value our f of x is very close to 0, and we can look at this graphically. So our root is over here, it's about 1.6768, that is shown graphically. The procedure we used, Regula Falsi method, gives more accurate value for the root. We can even try the first problem here. We can try to solve the algebraic equation. So similar algorithm, just the equation is different here. So the Regula Falsi method solves this problem in just 6 iterations. So we can even, the root is 0.381966, and at that value our f of x is very close to 0. We can look at this graphically, and the root is 0.38384. So the procedure we used, the Regula Falsi method, gives more accurate value than what we saw graphically. So as discussed before, if f of a times f of c is lesser than 0, then the root lies between a and c, and if f of a and f of c is greater than 0, the root lies between b and c. So our stopping criteria is given as bi minus ai should be lesser than or equal to the tolerance value epsilon 1, or the function f of x at c should be lesser than or equal to the tolerance value epsilon 2. To summarize, in this video we presented Regula Falsi or false position method to solve nonlinear equations. Regula Falsi method belongs to a group called closed domain or bracketing methods. Regula Falsi method is much more efficient than the bisection method in general, as it requires fewer number of iterations to solve to find the root of a nonlinear equation. So in the next video we can look at some open domain methods such as second method or Newton's method. Thanks for watching the video. If you have any questions, please post it.